Good afternoon, children. Good afternoon, online children.
Good afternoon, ma'am.
Good afternoon. So I shared the formulae based on spheres and hemispheres on WhatsApp. Okay? Yeah. Volume of a sphere 4 by 3 pi r cube. Total surface area. Total surface area. The outside area. The total surface area of a sphere 4 pi r square. 4 pi r square. All right? And the height of a sphere is equal to its diameter, 2r. R plus r, 2r. This is the radius of the sphere. Hemisphere, volume, 2 by 3 pi r cubed. We have seen this earlier. 2 by 3 pi r cubed. Curved surface area, only this area. Curved surface area, 2 pi r square. Total surface area, that is including the area of the top. Including the area of the top, 3 pi r square. And in a hemisphere, radius is equal to the height. The depth of the dowel, the depth of the hemisphere is equal to the radius of the hemisphere. This is a direct question. Find the volume of a sphere. Volume, this is the formula. Find the volume of a sphere. 4 by 3 pi r cube is the formula. And radius is given to you. The only unknown is r. 4 by 3 is a constant. Pi is 22 by 7. So you just have to substitute for r to find the volume. And r is 11.2. So 4 by 3, 22 by 7, 11.2, 11.2, 11.2. So first try to cancel, like simplify. And then you'll have to multiply all the numbers in the numerator, denominator, divide and get the volume. A shot put is a metallic sphere. Okay, sphere is a shape, spherical. Metallic, made of metal. Okay. A shot put is a metallic sphere of radius 4.9. See, for a sphere, if you're given the radius, you can calculate volume, you can calculate a surface area, everything. You just need the value of R, and that is given to you. If the density of the metal is 7.8 grams per centimeter cubed, 1 centimeter cubed of this metal weighs 7.8 grams. This shot put is made of some metal, right? That metal, 1 centimeter cubed of that metal, that volume, 1 centimeter cubed is volume, right? Centimeter cube itself is a unit for volume. 1 centimeter cube of that metal has a mass of 7.8 grams. If this is given to you, you are asked to find the mass of the shot put. Then what is the mass of the shot put? So clearly you'll have to find the volume of the shot put. Volume, you should find the volume of the shot put. So say the volume is, say some 10 centimeter cube. The volume of the shot put is, we work for 4 by 3 pi r cubed, and you say you get 10 centimeter cubed. So now how do you find the mass? 1 centimeter cubed has a mass of 7.8 grams. So 10 centimeter cubed will have a mass of 10 into 7.8. It's like one book, 7 rupees 85 paise. So 10 books will be 7.8 into 10. 1 centimeter cubed, 7.8 grams. 10 centimeter cubed will be 10 into 7.8. We are given that 1 per centimeter cube, 1 centimeter cubed of this metal. The shot put is made of some metal, right? 1 centimeter cubed of that metal has a mass of 7.8 grams is given to you. Like the fruit seller tells you, 1 kilogram of apple is 200 rupees. 1 kg of apples, 200 is all he can tell you. He will not tell you for 2 kgs or 5 kgs or 10 kgs. So depending on how much you want to buy, you will decide, you can calculate the cost. He will tell you 1 kg is 200 rupees. So similarly here, 1 centimeter cubed of this metal has a mass of 7.8 grams. So you should find out how much centimeter cubed is there in the shot put, meaning what volume of metal is in the shot put, using the formula 4 by 3 pi r cubed. So see here, radius is given, volume is equal to 4 by 3 pi r cubed, 4 by 3 pi, 4.9, 4.9, 4.9, simplify and all this is the volume. Mass of 1 centimeter cubed of metal is 7.8 grams. So the mass of the shot put will be, there's a typing mistake here, I'll just correct it. It will be 493.005 into 7.8. This into 7.8. Correct? I've forgotten to write 0.005. That's it. 1 centimeter cube, 7.8 grams. For 493.005 centimeter cube will be into 7.8. So you get so many grams. Convert that to kilograms. You get 38. You get 3845.4 grams. So it will be 1, 2, 3. It will be 3.8454 kilograms. You can just round it off to 3.85 kilograms. So what should you do here? Find the volume. Find volume, multiply this by 7.8. You will get the answer in grams. Convert grams to kilograms by dividing by 1000. And then just round off to 3 decimal places. Okay, I'll just correct this part, okay? You can round it to 3 decimal places. That's it. A hemispherical bowl has a radius of 3.5 centimeters. Hemispherical, okay, has a radius of 3.5 centimeters. What would be the volume of water it would contain? Volume 2 by 3 pi r cube. Direct. Correct? Yes. Radius is given. Radius is 3.5. Volume 2 by 3 pi r cube because it's hemispherical bar. Okay. You'll have to find the volume of a sphere given the radius. Volume of sphere 4 by 3 pi r cube. And you're given the value of r. These are two different questions. So just put the value of r and calculate. I'm not, so since these are very basic, I'm not going to share the answers. You have to work, calculate, and then we'll check if we are getting the same answer. All right. Find the amount of water displaced by a solid spherical ball of diameter 28. So radius is 14. Diameter 0.21. So the radius is 0.21 by 2. You can even substitute radius like this. Not that you should see radius, you can, what's the formula? 4 by 3 pi r cube. 4 by 3 into 22 by 7 into 0.21 by 2 into 0.21 by 2 into 0.21 by 2. It's not that you have to divide and find the decimal value. You can go ahead with 0.21 by 2. That's your choice. The second one I'm saying, the second one, 4 by 3 into 22 by 7 into r cubed. This is a diameter, radius. So r cubed, radius, you can cancel 2, 2 and 4. correct? And then 2 ones are 2, 11 times. 7 ones are 7, 3s are is 21. 0.3. No, 0.03. 0.03. Then 3, 0.07. That's all. See, finished. Finished. Now you just have to multiply 11 into this, into this, into this. So how do you multiply? 11 threes are 33. Then 33 into 7 into 21. 11 into 3 into 7 into 21. And then place the decimal points. So 1, 2, 3, 4, 5, 6. So the product should have 6 decimal places. That is after the decimal point, 6 digits. Multiply 11, 3, 7, and 21. Get the product. How many decimal places? 2, 4, 6 decimal places. So you should place the decimal point in such a way that there are 6 digits after it. That's the answer. See, you can, now what I explained, you can do like that. Or you can also do this. You can also do what? Like I've divided by 2. I found the decimal value. Then I converted that to a fraction. What is 0.105? 105 by 1000. 105 by 1000. Correct? Then simplify, you get 21 by 200. When you simplify, you get 21 by 200. So you can use that also here. R is 21 by 200. So it's completely left to you. You can just go ahead with 0.21 by 2. Or you can divide and get the decimal value 0.105. And again, you don't want the decimal point, so you can convert this decimal to a fraction. You can convert the decimal to a fraction. And you can simplify. How many times? 21 and 200. 21 by 200. So this is the radius. And you can substitute that. 21 by 200. I showed you with 0.21 by 2 itself. Okay. So anything is fine. But be careful. Diameter. So if you do everything, calculation, everything is perfect, but you have taken the radius as 28, your answer is wrong. So that's diameter. So again, everything perfect, but you've taken the radius as 0.21. Nobody will show sympathy and so sad. He's done so much of calculation correctly. Okay, it's okay. Let us, award him the marks. No, will not get marks. Be careful. Read if it is the radius or the diameter. Similar question, no? 1 centimeter cubed, 8.9 grams. 1 centimeter cubed, 8.9 grams. So you should find the volume of the of this metallic ball. Diameter is given. Diameter is 4.2. So radius is 4.2 by 2. 2.1 is the radius. Find the volume of this metallic ball. It's spherical. A ball is spherical. So no question whether it's a hemisphere or a sphere. It's a metallic ball, so it's spherical. It's a sphere. So the formula to find the volume is the metallic ball. So it is a sphere. So 4 by 3 into 22 by 7 into 2.1 into 2.1 into 2. Get the volume and multiply that with 8.9. Correct? Because 1 centimeter cubed, 8.9 grams. Let me just sneak and see what the volume is. Yeah. Here. Volume you get is 38.808 centimeter cube. So 1 centimeter cubed, 8.9 grams. 38.808 centimeter cube will be into 8.9. So what you see here is actually, 1 centimeter cubed, 8.9 grams. 38.808 centimeter cube will be this into this divided by this. That's how it's done. This number, we know we have to multiply these two. but it's this number into this number divided by this number. This number into this number divided by this number. So it is 38.808 into 8.9 divided by 1. So when you multiply this, you get this one and you can round it off. So this is the mass of the ball. You don't have to round, you don't have to convert that to kilograms because it's 345 grams. It's less than 1000 grams. It's less than 1000 grams. So you leave it in grams. If it's more than 1000 grams, you have to convert it to kilograms. This is only 345 grams. So leave it like that. The diameter of the moon. There are two things in this question, moon and earth. Moon and earth. So we know that in size or in volume, the earth is bigger than the moon. The earth is bigger than the moon. What is the diameter? Twice radius. Diameter is twice radius. As I read, I'm going to construct the equation. The diameter of the moon, correct? Yes. Is approximately 1/4 of the diameter of the earth. Correct? Diameter of the moon is approximately 1/4 of the diameter of the earth. Cross multiply. Correct? Stop here. What should you find? What fraction of the volume of the earth is the volume of the moon? So which is the smaller one here? Moon, right? And the bigger one is the earth. So like if you have to find what fraction of the class are boys, what fraction of the class are boys? So it is number of boys by the total strength of the class. Correct? Yes. What fraction of the class are boys? In a boys' school, they'll not ask this question. In a co-education school, this question holds good, right? Okay, so it will be number of boys by total number of students in the class. In the same way here, it will be the volume of the moon by the volume of the earth. See, when it is boys and class, this is the full thing, right? Similarly, when it is moon and earth, okay, see, when it's class, when it's boys and class, you write class in the denominator. So when it is moon and earth, you must write earth in the denominator. What fraction of the volume of the earth is the volume of the moon? So it will be volume of moon by volume of earth. That's the meaning actually. It's not because earth is bigger or something. It's because that's what it means. You can just substitute something here. Then you'll understand. See, like what fraction of the class are boys? What fraction of the class are boys? So it will be number of boys by the total number of students in the class. So similarly here, boys is the second one, right? So volume of moon by the volume of earth. So that's what you'll have to find. This fraction is what you'll have to find. Volume of moon by volume of earth is what you have to find. What's the volume of moon? Spherical. 4/3 pi r cubed by 4/3 pi r cubed. Cancel. Correct. R cube by, what is R? 4R. 4R. Don't put 4R cube like this is wrong. 4R the whole cube.
Ratio 1 is to 4.
Huh?
The ratio is 1 is to 4.
So R cube by 64 R cube. R cube cancels, so the ratio is 1 by 66. 1 by 64. All right?
Okay.
Got it, children?
Yes, please.
We need to find the volume of the moon by the volume of the earth. Both are spheres. So 4 by 3 pi small r cube by 4 by 3 pi capital R cube. 4 by 3 and pi gets cancelled in the numerator and denominator. And then we know this capital R is 4 times small r. Here we have it. So we substitute. Instead of capital R, we use 4 times small r. The whole cube. Then this is 64 r cube. The r cube gets cancelled and 1 by 64. That's what you have here. This one also. Hemispherical bowl. What bowl? Hemispherical bowl, not a sphere. Okay, so hemispherical bowl. So what's the formula to find the volume? 2 by 3 pi r cube. 2 by 3 pi r cube. So you need to find the volume and then convert that to liters. This is the conversion. I'll just take the volume answer. 303. This is the volume of the hemispherical bowl. All right. Now you'll have to convert this to liters. The conversion is 1000 centimeter cube is 1 liter. You need to remember this. 1000 centimeter cube is 1 liter. If 1000 centimeter cube is 1 liter, then 303.1875 centimeter cube will be how many liters? This number into this number divided by this number. 303.1875 into 1 divided by 1000. Shall we shift the decimal point? 3, 1, 2, 3. So it will be 0.3031875. Oh my God. So it will be, you can, when it is in liters, you can just have 3 digits after the decimal point. So 0.303 liters, which means it is 303 milliliters. 303 milliliters. That's why 3 digits we should have after the decimal point. That's it. So what did I say? When you find the volume of the hemispherical bowl, the answer will be 303.1875 centimeter cube. Now what to do with this? Write the conversion rule. 1000 centimeter cube is equal to 1 liter. Then 303.1875 centimeter cube will be, multiply these two, 303.1875 into 1 divided by 1000. So you should write it correctly. Centimeter. Here see you have centimeter cube. And here this is in liters. This answer also is in liters. On the left hand side, the unit, right hand side unit will be the same. On the left hand side, what unit you have? Centimeter cube. On the right hand side, liters. So this answer will be in liters. If you write like this, 1 liter is 1000 centimeter cube. Then you must write like this. Then 303.1875 centimeter cubed is equal to. If you see, you write it like this, but just in case you write 1 liter is 1000 centimeter cube, then you must write below centimeter cube, you must write this 303.1875 centimeter cube will be this into this divided by this. We have to convert this to liters, right? So you should always write the rule like this only. 1000 centimeter cubed is equal to 1 liter. What you have here. Now this one is a hemispherical tank. It's made up of iron sheet, 1 centimeter thick. A hemispherical tank is made up of an iron sheet 1 centimeter thick. All right. If the inner radius is 1 meter, the inner radius here, inner radius is 100 centimeters because 1 meter is 100 centimeters. It's 100 centimeters. Find the volume of iron used to make the tank. Find the volume of iron. Iron is a material. They're not asking you how much liquid this tank can hold or how much water the tank can hold. They're asking you the volume of iron. How much iron, how much material, what is the volume of the material used to make the tank? All right. Okay. Now, yeah, just give me some time. Okay. Now, please imagine this. Imagine a solid hemisphere. A solid hemisphere. So like this, this cork ball is a solid sphere. A cork ball is a solid sphere. When you cut that into two equal parts, each half is a solid hemisphere. When you cut a cork ball into two equal pieces, each half is a solid hemisphere. Now what you do, now this is that solid hemisphere. What you do, you scoop out, you remove a smaller hemisphere from this solid hemisphere, you scoop out a hemisphere having the same center, but a smaller radius. So when you scoop it out, no, you scoop it like this. You scoop out a hemisphere like this. That hemisphere also has the same center, but a smaller radius. Supposing this radius is 5, this radius is 3. Supposing the radius of the solid hemisphere you have already, that half a cork ball. If the radius of that is 5, you're scooping out because it's solid, no? So you can scoop. So you're removing you're removing a hemisphere using the same center but a smaller radius, say 3 centimeters. So now the resultant object is what this tank will look like. That's how a tank where the material is thick, you can imagine. So this, when from a solid hemisphere, you remove another hemisphere with the same center but a smaller radius, the resultant, solid, what remains is actually called a hemispherical shell. It's called a hemispherical shell. What's a hemispherical shell? From a solid hemisphere, if you remove a hemisphere with the same center but a smaller radius, the resultant solid is a hollow hemisphere or a hemispherical shell. And that's what we have with us. So the volume of this iron, will be the external volume minus the internal volume. What is the external volume? The volume of that solid hemisphere you had originally, 2 by 3 pi r cubed. You had this. From that you took away 2 by 3 pi r cubed. You actually had a solid hemisphere whose volume was 2 by 3 pi r cubed. From that you're scooping out a hemisphere with a smaller radius. So you've removed this. You've removed this. So when you subtract these two, you will get the volume of the remaining thing, which is the volume of the uh, iron used to make the tank. So we have a formula which says volume of the material is equal to external volume minus internal volume. External volume minus internal volume. 2 by 3 pi capital R cube minus 2 by 3 pi small r cube. So see the details. Small r is 1 meter, 100 centimeters. The thickness is 1 centimeter. So the capital R, the value of capital R will be from here to here it is 100 and this thickness is 1. So capital R is equal to 101. Correct? Correct? From here to here, small r is 100 centimeters. From here to here, the thickness 1 centimeter. So the value of capital R will be 101. This is 1 meter. Don't add 1 meter and 1. Don't try to add this and write 2. Both of them should be in the same unit. 1 meter is 100 centimeters plus 1 centimeter. 101 centimeter. Correct? Okay. Inner radius 100 centimeters. Thickness 1 centimeter. Outer radius, inner radius plus the thickness. 100 plus 1, 101 centimeters. The volume of iron used to make the tank is equal to the external volume, 2 by 3 pi capital R cube, minus the internal volume, 2 by 3 pi small r cube. Because this solid hemisphere was there originally, and this is removed. Only when you do that, such a thing remains. So this is the formula to find the volume of iron used to make this tank. So you can take out 2 by 3 pi common, r cube minus r cube, substitute and calculate. Just give me 2 minutes, children, go through this. In this question, find the volume of a sphere whose surface area is 154 centimeters square. To find the volume of this, to find the volume of a sphere, what is the formula? 4 by 3 pi r cube. So you need to know the value of r, but that's not given. Instead of that, you have a different information. Surface area is 154. Okay, what's the formula to find the surface area of a sphere? 4 pi r square. That is given to be 154. 4 pi r square is equal to 154. So you must solve this equation and find the value of r and then find the volume. Now you cannot find volume because you don't have the value of r. To find the value of r, they have given you this information. 4 pi r square is equal to 154. So solve this, find the value of r and then find the volume. See. 4 pi r square. Yeah, ignore that. It's coming from you. You can change your phrase if you're not comfortable. So surface area of the sphere is 154. 4 pi r square is 154. 4 into 22 by 7 into r square is 154. So r square is equal to transpose. 22 by 7 becomes 7 by 22. 4 by 1 becomes 1 by 4 on the other side. And cancel. You have r square is equal to 7 into 7 by 4. 7 into 7 by 4. So r is equal to square root of 7 into 7 by 4. R is equal to square root of 7 into 7 by 4. So from 2 sevens, 1 7 out. And square root of 4 is 2. So r is equal to 3.5. Now, you have the value for r. 4 by 3 pi r cube is the volume. R is 3.5. And this is the volume. All right. What is the question? To find volume of sphere. What do you need? The value of r. Is that given? No. To find the value of r, they've provided you with some other information. What is that? Surface area of the sphere is 154. Why is that given? That is given because they have not directly given you the value of r. They have given you that information. You have to work and find the value of r yourself and then find the volume. So the equation is 4 pi r square is equal to 154. Solve this and find the value of r and hence find volume. Let's just, before we go to this, we'll just understand a general equation. So cost of one book into number of books is equal to the total cost or the total money you spend on books, right? All right. So like cost of painting 1 meter square into number of meters square, meaning into the curved surface area or the total surface area, whatever area you have to paint. Now, what is this? This question is about a dome of a building, which is in the form of a hemisphere. And from inside, it was whitewashed. Okay, so that's the situation. You're inside a building, you look up, the ceiling is not flat. It's a dome. Okay, you enter a building, you look up at the ceiling, it's not flat, it's a dome. And the dome is whitewashed. Whitewashing, before you paint, it's whitewashed and then it's painted, right? You give a white color, on that you apply the paint. Okay, so you look up, you can see the hemispherical dome. So what part of the dome can be whitewashed? The curved surface area. Because the circular, what is the shape of the mouth of a hemisphere? What is the shape of the mouth of a hemisphere? Circle. Circle. But that circle will not be covered, no? When you look inside, that circular part will not be covered. Then you cannot see the shape, no? The hemispherical shape. So this part of the dome is to be painted. This part of the dome is to be painted. This is the building. This is the building. You look up, and this part of the building, this part of the dome has to be painted. This part of the dome is called the curved surface area. Because if you paint here and here, then this is CSA and this is the area of the base. Together that will be the total surface area. But here circular part, there's nothing to paint. You can only simply put the brush in the air like that. Okay, only the curved surface area can be painted or whitewashed. So here, cost of whitewashing 1 meter square. Whitewashing, this is WW is whitewashing. Cost of whitewashing 1 meter square into the curved surface area. Like if the curved surface area is say some 50 meters square. So the cost of whitewashing 1 meter square into 50 meters square will be the total cost, right? Total cost. For 1 meter square, the cost, whatever is the cost for whitewashing 1 meter square, that one into the curved surface area will be the total cost. Now, how will you calculate the total cost? Like the painter, you finished that? Yeah, I'm just coming. So the painter tells you for painting 1 meter square, it is 20 rupees. The painter tells you to paint 1 meter square, 20 rupees. So then how will you calculate? You will find out the curved surface area of of the dome. And if that is 50 meters square, he told you 1 meter square, you'll have to pay me 20 rupees. So you find the CSA of the dome. It's 50 meters square. It's 50 meters square. So you have to pay him 50 into 20,000 rupees. Okay. So the cost of painting or whitewashing 1 meter square into the number of meters square. That is the CSA. Is the total cost. Is the total cost. So the inside surface area into the rate is the total cost. So the inside surface area will be the total cost by the rate. So this is the inside surface area. Let me read the question for you. A dome of a building is in the form of a hemisphere. From inside, it was whitewashed at the cost of rupees 4,989.60. If the cost of whitewashing is rupees 20 per square meter, find the inside surface area of the dome and the volume of the air in the dome. All right? Just go through this answer. I'm just coming. So the inside surface area is equal to the total cost by the rate. This is called the rate. 20 rupees per meter square is the rate. The total cost divided by, because this will come for division, right? This will come here for division. So the inside surface area is equal to the total cost divided by the rate, 20 rupees. So when you divide that, the inside surface area is 249.48. So that means what? 2 pi r square. The first question is to find the inside surface area of the dome. That is this. Next, you need to find the volume of air in the dome. For that, the formula is 2 by 3 pi r cubed. This is the formula. To find, see, the first part of the question we answered. The first sub question we've answered. See, we got it. For 1, this is the answer. Now 2. 2 is to find the volume of air. To find the volume of air, the formula is 2 by 3 pi r cubed. You need the value of r. R is not known. Read the question, R is not given. So you have to work this. You know that the CSA, 2 pi r square is equal to this number. What is inside surface area? CSA. Okay. Inside surface area meaning CSA. You know the CSA is 249.48. So there's an equation now, 2 pi r square. CSA is 2 pi r square. This one is 2 pi r square. 2 pi r square is equal to this number. So work that and find the value of R. Find the value of R. And then find the volume of the air in the dome, 2 by 3 pi r cube. All right? You must use this equation, 2 pi r square is equal to 249.48 to find the radius and then find the volume of air in the dome. "27 solid iron spheres I'm not drawing all the 27 of radius r 27 solid hemispheres of 27 solid iron spheres, so spherical, of radius r and surface area s. Surface area is s. Surface area is s. Surface area s. Surface area s. 27 like this. They're all melted. All of them are melted and they made into one big sphere with surface area S dash. The surface area of the new sphere is S dash. You must find the radius R dash of the new sphere. What is the radius R dash of the new sphere? Then you should also find the ratio of S to S dash. What is S? The surface area of one small sphere. And what is S dash? The surface area of that new big sphere. You must find S to S dash. Do I frighten you? Okay. See here, so what do we have? We have 27 small spheres, each of radius r and surface area s. All these 27 spheres are melted and made into one big sphere of radius r dash and surface area s dash. You need to find the radius r dash of the new sphere, and you should also compare the surface area of the small sphere to the surface area of the big sphere. All right? S by S dash. Okay. Now, when all these 27 are melted and made into one sphere, their volumes will be the same. Volume of the new sphere or the volume of the big sphere is equal to 27 into volume of one small sphere. Is this correct? Or how is that big sphere formed? From all these 27 small spheres. So volume of that big sphere will be equal to 27 into volume of one small sphere. Volume of one small sphere into 27 will be the volume of that big sphere. Supposing the small spheres, no, each were like some 30 grams, 30 grams. So what will be the mass of that big sphere? 30 grams into 27. Correct? 27, so. So that's the equation. Now the formula. Volume of the big sphere, 4 by 3 pi capital R cube. Sphere. Be careful. Sphere, not hemisphere. 4 by 3 pi. Oh, no, I should not use capital R because they've given you the radius, no? 4 by 3 pi R dash cubed. Why? Because that big sphere radius is R dash. 4 by 3 pi R dash cubed is equal to 27 into 4 by 3 pi R cube. So small space, you can just do this in the rough column. Radius R, surface area S. Big sphere, R dash, S dash. So what is the radius of the big sphere? R dash. Small sphere, R is given in the question. Surface area S dash. So 4 by 3 pi R dash cube is equal to 27 into 4 by 3 pi R cube. 4 by 3 pi, 4 by 3 pi cancels on both the sides. R dash the whole cube is equal to 27 R cube. So R dash is equal to the cube root of 27 R cube. 3R. 3R. The cube root of 27 is 3 and the cube root of R cube is R. So 3R. R dash is equal to 3R. That's the answer to the first sub question. Radius R dash of the new sphere is 3R. Now you need to find the ratio S to S dash. S to S dash. What is S? 4 pi R square by 4 pi R dash square. So R square by, what is R dash? 3R. What is R dash? 3R. So 3R into 3R, 9R square. 1 is to 9 is the ratio. 1 is to 9 is the ratio.
Akka, they're unmuted.
Okay. This is simple one. This is the last question in this exercise. A capsule of medicine is in the shape of a sphere. Sphere of diameter 3.5 mm. How much medicine is needed to fill this capsule? So volume, if you're going to stuff something inside, it's volume. If you're doing something on the surfaces, it's curved surface area or total surface area, which you have to calculate. If you're filling something into the, the solid, then it's volume. How much medicine is needed to fill this capsule? So clearly you'll have to find the volume. Sphere, so 4 by 3 pi R cubed, and the diameter is 3.5. So radius is 3.5 by 2. I told you 3.5 by 2 is 1.75. You can take 1.75 as radius, or you can take 3.5 by 2 directly. 3.5 by 2 into 3.5 by 2 into 3.5 by 2. And that will be the quantity of medicine that is needed to fill the capsule. All right, children, I'll just share the images on WhatsApp. It started at about 3:15, so your class will go on till. No. Yeah, 3:15. Yeah, so your class will go on till 5:15. So you have to stay in the meeting till 5:15. Complete this work. Okay, don't leave the meeting until I wind up the meeting, until I tell you to leave the meeting. Yeah, I'll share the images on WhatsApp. Please start working.